Astronomical friends, this is Mohammed Inam. Today I am going to speak about Heaviside expansion theorem that is very useful for those who don't remember tables. If you like my video, then kindly subscribe my channel. Theorem statement says that let f bar of s equals to Laplace of f of t and g bar of s equals to Laplace of g of t be two polynomials in S, where the degree of f bar of s is less than the degree of g bar of s. First condition, and g bar of has n distinct roots. Distinct roots means they may be complex, they may be real, but they not be repeated. Then the Laplace inverse of this form of function can be easily found out by this easily simple steps. For the sake of learning more, we have one example, and I'm going to show. So friends, we have one example, so I'm going to solve this one by using Heaviside expansion theorem statement. From the theorem statement, we have Laplace inverse of h bar of s equals to summation up to I equals to 1 up to n f bar of s divided by g bar prime of s e power alpha I t, and this is not s, sorry, this is alpha I. For alpha I, of course alpha I are the roots of the g bar of s, so let's say this is f bar of s and this is g bar of s. So alpha g bar of s equals to 0 equals to s minus 3 s plus 2 and s square plus 1. So roots are 3 minus 2 and plus minus iota. For theorem, we have to compute g prime. So I have already computed g prime. I am going to show you direct results. 4s cube minus 3s square minus 10s minus 1. Now we have all the things. We have to compute the result. From this, it means that f of 3 g bar prime of 3 e power 3t first term plus, because we have n are 4s, you can see here n 1 2 3 and 4, we have 4 n, so we have only 4 terms here. F of minus 2 e power minus 2t divided by g bar prime of minus 2 plus f of iota divided by g bar prime of iota e power iota t plus f of minus iota g bar prime of minus iota e power minus iota t. Now we have to compute these 4 terms. So I am going to evaluate this first term, then second, then third, and so on. So for f of 3, if this is f of 3, so 3 times f of 3 square, it's 9, plus 2 times 3, it's 6, and minus 3, so 12. We have 12, and at for the derivative we have g prime of 3, so g bar prime of 3 equals to 3 cube means 27 minus 3 times 3 square means 27, again minus 10 times 3 minus 1, it will be 50. Then e power 3, it is simplifying, then we have 6 over 25. So for the first term is e power 3t, adding here, and e power 3t e power 3t. So we have our first result. So now I can directly show you all results for the sake of time. What we have, the first term, I'm going to write this to show you what is the first term, second term and third term. Six over 25 e power 3t plus 3 over 25 e power minus 2 times t minus 9 minus 13 iota divided by 50 e power iota t minus 9 plus 13 iota over 50 e power minus iota t. I am showing direct result for the sake of time. I don't want to kill your time, so direct results we have. So now we can change, for instance of real solution, we can change these two terms into sine or cosine. So minus 9 over 50 e power iota t minus 9 over 50 e power minus iota t and minus 13 iota over 50 e power iota t plus 13 iota over 50 e power minus iota t. If I am getting common, minus 9 over 25, so we have e power minus iota plus minus e power minus iota t over 2. Here plus 13 over 25. So we have minus iota e power iota t plus iota e power minus iota t divided by 2. So this is cosine minus 9 by 25. This is cosine t and this is plus 13 by 25. This is sine t. Now we have real solution. So we can say that Laplace inverse of h bar of s equals to 6 by 25 e power 3t plus 3 by 25 e power minus 2t minus 9 by 25 cosine t plus 13 by 25 sine t. We have done. This is the Laplace inverse of this function by using simple computations. Thank you.